Good day, everyone, and welcome to today's DevOps.com webinar. Excited that you've joined us. Got a really good topic: connect ops and security with flexible web app and API protection. API protection is all the rage right now. Everybody's talking about this and trying to figure out the best approaches. We're very happy to have Signal Sciences supporting our webinar today as our sponsor. My name is Mitch Ashley. I'll serve as your host and moderator. Now, a couple housekeeping items. We are recording the webinar, and all attendees will receive an email with a link to the recording, as well as a copy of the slides. So sit back, relax. You can take a few notes if you want, but you're going to get the slides, so you'll have all this information handy. Also, at the end of today's webinar, we'll be giving away 4 $25 Amazon gift cards. So please hang out and find out if you're one of our winners. Now, we have 2 speakers today. I know both of them love questions, and they really would appreciate any that you might ask. So just pop them into the questions tab of the GoToWebinar software. So let's jump to our topic: connect ops and security with flexible web app and API protection. Our 2 speakers today: first, we have Orlando Barrera II and Anil Dadani, who both are technical account managers with Signal Sciences. Hopefully, Orlando, I hope we got your name right there. Orlando,
That's fine.
I'm going to turn it over to you. All right, here you go.
All right, appreciate it. Thanks, Mitch. Hi, welcome everyone, and thank you for joining our webinar today. Connect ops and security with flexible web app and API protection. So our agenda today. We're going to briefly be taking a look at some of the deployment options available using Signal Sciences and how you can bake layer 7 security into your CI/CD pipeline. We will briefly discuss the shift from monolithic to API and microservices driven applications and how security must shift as well from a legacy to a next-gen WAF approach. We will also consider how ease of integration into the CI/CD pipeline and a comprehensive coverage can reduce friction between teams when deploying our next-gen WAF. Lastly, we will walk through a demo example of integrating into a configuration management solution using Ansible and Docker. My name is Orlando Barrera. I am a technical account manager at Signal Sciences. Prior to joining Signal Sciences, I worked for several years with Rapid7 and NSS Labs. I'm also a U.S. Army veteran, airborne. I've also presented at several conferences, including B-Side Las Vegas, RSS, LastCon, and HughesCon. I hold a bachelor's degree in computer science from Texas State and have a CISSP and Security Plus certifications. I'm joined today by my co-presenter, Anil. I'll let him present himself. Anil.
Thanks, Orlando. As Orlando mentioned, my name is Anil Dadani. I'm also a technical account manager at Signal Sciences. Our main goal here is to provide post-sales, empower our customers in the post-sales process for delivering application security success. And I'm actually a board member of the OWASP and Cloud Security Alliance LA chapter here in Los Angeles. Prior to Signal Sciences, I actually worked at Rapid7 as well with Orlando. We were in different teams, obviously, but I actually helped start the managed services program out at Rapid7. I also hold a bachelor's degree, but in information systems from the University of Wisconsin.
Awesome, appreciate it. Thanks, Neil. So discussing today, we're going to begin with the challenge. The challenge is protecting, as Mitch mentioned, apps and APIs across various infrastructures. Signal Sciences protects some of the largest volume traffic websites on the internet. Our customers span many industries. We secure healthcare startups, media conglomerates, large enterprises, streaming providers, video game platforms, and financial services firms. Across these industries, we partner with our customers to leverage different types of infrastructure to serve their customer bases. When you think about your current application deployment and security posture, how comfortable are you answering these questions? Answering these questions today is a lot harder than it was a few years ago. Your organization likely operates multiple applications, has an expansive footprint of apps, APIs, and microservices running on a hybrid mix of hardware, cloud, and containers. So ask yourself, what is your current risk exposure? The solution, Signal Sciences. a next-gen WAF that can provide web layer visibility for applications no matter where they operate. Signal Sciences can provide security and visibility to your applications in a seamless manner. Our solution has the flexibility to secure any combination of cloud provider, data center, web server, load balancer, language, or container orchestration framework. Whatever your organization uses to deploy applications, we support it. Comprehensive attack coverage is crucial to ensure proactive defense, outstanding visibility, and actionable insights. This is the Signal Sciences web application and API protection platform, and the component offerings that defend against the common and advanced web attacks, from OWASP Top 10 injection attacks to bad bots, API abuse and misuse, to denial service attacks. Our web application and API protection platform is built upon intelligent request inspection and decisioning, combined with our ability to deploy in any environment. This provides holistic web security that meets the needs of our customers to defend against many types of web attack scenarios. We are currently seeing an increase of account takeover attacks, where attackers trying to gain access through authentication endpoints by either using compromised credentials from common password lists or credentials found on the dark web. We also help defend against abuse from known malicious sources, such as Tor, SANS malicious IPs, and Signal Sciences' own IP reputation-based feed. Advanced rate limiting from Signal Sciences thresholds anomalous, high-volume web requests, while allowing legitimate traffic through to your application endpoints. Signal Sciences' patented agent runs natively in any cloud, data center, or container. This allows for several flexible deployment options at the code layer, web server, API gateway, or cluster ingress. Our architecture was designed for easy deployment of our agents, regardless of the underlying server, instance, OS, or code language. Installation is simple, allowing you to secure your applications, APIs, and microservices in minutes. Our hybrid SaaS includes three main components: the agent and module, and the cloud engine. The agent module is server-side software you install on your infrastructure within minutes via via public repositories and configuration management tools. The Signal Sciences agent module interaction is a patented design created by our founders from their experiences securing traffic at scale for Etsy. The cloud engine is our cloud-hosted analytics backend, which updates the agent asynchronously with intelligence gathered from external and proprietary sources to make dynamic, application-specific detections. A single platform that provides the visibility and instrumentation necessary to detect and stop advanced web attacks in production without high false positives. The Signal Sciences team, our Signal Sciences team provides you visibility into what users are doing, how the apps are being accessed, and anomalies within those applications. The web dashboard provides insights into what types of vulnerabilities your apps are seeing and how traffic is handled. The array of integrations gives teams security telemetry via alerts, Datadog, Slack, PagerDuty, and several other options. Signal Sciences' focus on low false positives will help separate legitimate attack vectors from noise, reducing alert fatigue. The traditional approach is for a security team to identify a vulnerability, and the ownership to fix the issue is on the development team, causing friction or delays. Signal Sciences allows teams to abstract security while providing visibility into application traffic. The move to microservices allows us to secure apps in a new, better way. When dozens of services are talking to each other over HTTP, and new applications can be deployed in days, a WAF needs to be deployed alongside or in front of each service. This configuration protects microservices and ensures a WAF is flexible enough to protect any tier or service-based model. So working previously with a desk team on a web app scanner product for Rapid7, we had a saying: you can't scan what you can't see. Well, you could say something similar about a WAF. You can't secure what you can't see. Having insight into your application traffic and a holistic view of attacks is essential for the mitigation of web application security risks. Signal Sciences helps provide that single pane of glass visibility into all of your infrastructure, from legacy monolithic, containerized, or cloud-native applications. So how does our agent work? Smart Parse. Smart Parse is our proprietary detection method designed to make instantaneous decisions in line to determine if there are malicious or anomalous payloads present in a request. By evaluating the context of the request and how it would actually execute, we're able to make highly accurate decisions. Smart Parse is tested at scale with over 250 billion weekly production requests, requires no tuning or configuration, and virtually eliminates false positives. Smart Parse is used in the detection of all attack signals. So now let's talk about the Signal Sciences SaaS architecture. We provide customers an application protection that proactively monitors for malicious and anomalous web traffic directed at your applications, APIs, and microservices wherever they run. It could be cloud, on-prem, containers, or hybrid environment. The system is comprised of three key components: a web server integration module, a monitoring agent, and our cloud-hosted collection and analysis system. The agent and module are deployed and run within your infrastructure, as shown in the deployment options section of the graphic at the left. They analyze and act on malicious traffic in real time as it's detected. Anomalous request data is collected locally and uploaded to our collectors, allowing us to perform out-of-band analysis of malicious inbound traffic. The patented agent module pair inspects web requests and decisions with a fail-open architecture. What this means is if the agent ever crashes, your application does not go down because the module fails open if it doesn't hear back from the agent within a configurable set time limit. Now, the cloud engine provides visibility, context, and actionable insights via API, alerts, metrics, and event reporting in web dashboards. Our web dashboard is API first. So any data you see in the dashboard, you can pull out from the Signal Sciences API. Now, what does all this mean for your organization? It means your next-gen WAF can change in step with your applications. Now, the only constant is change. The Signal Sciences SaaS solution is architectured to scale with your organizational needs. Our next-gen WAF can align with your digital transformation journey and bake into your existing CI/CD pipeline. Within these day-to-day challenges, security stakeholders need to protect apps deployed across cloud, data center, containerized workloads are a hybrid of these. I know some of you may be saying, Orlando, we already have a WAF, right? Like, not sure why we need to consider additional tooling to protect our apps and APIs in production. So a brief word on legacy WAFs. They're relying on antiquated, regular expression pattern matching. And in a nutshell, that technology is not adequate for today's modern distributed apps. And frankly, it doesn't scale effectively. We've seen our customer traffic volume increase over time, but that increase has been pronounced more so beginning in March when the trend to work remotely began. Companies adopted remote working, customers started transacting even more online via web and mobile apps, and since March, we've seen a 27% increase in that traffic. More web applications and APIs are in use today than ever before, and that usage has multiplied due to the pandemic. Everyone has been forced to shift their digital transformation timelines ahead by years. The companies need a security solution that work with what they already have in place and integrate with tools that they already use. They need solutions that don't require significant tuning to begin protecting the rapidly growing list of applications, and they need something that works out of the box. Now, as organizations are migrating from a traditional monolithic architecture to containers, the lift and shift, or a cloud native approach, the trend seems to be going from containerizing an application, then moving to microservices within the container, releasing additional API endpoints and microservices, which are updated and changed often. Signal Sciences protects containerized applications in production and provides fast time to value with immediate visibility into both north-south and east-west traffic. We offer superior advanced attack protection that legacy WAF appliances simply cannot match. Your traditional WAF layer 7 protection falls short in terms of protecting cloud-native applications. As the deployment and development teams have evolved with the progression to container world, the security tools that once worked within a traditional server or VM no longer scale with cloud-native applications. Signal Sciences WAF can scale up and down with your containers to provide layer 7 protection to your microservices with a lower total cost of ownership. Now, this evolution of hosting applications from monolithic to microservices, Signal Sciences can be there to help teams in that journey and provide the flexibility to work on each service in parallel with fewer interdependencies. Our next-gen WAF can keep pace with the rapid change of your applications by integrating into your already existing CI/CD pipeline. The term shelfware, well, that doesn't apply to our WAF. 95 of our customers are in full blocking mode. So let's take a look at the difference between a traditional WAF and a next-gen WAF. The traditional WAF requires rule-based detection and may provide some learning mode capabilities. However, due to the high rate of false positives, this would increase the amount of time it will take to switch the WAF to block actual attacks. Changes in code will require more time for the WAF to learn and constant tuning of rules in order to effectively operate. Deployment options are limited and it can't scale with your app. If there's an increase in the traffic, the WAF does not scale, which in turn can impact the performance of the application. The deployment time is typically measured in months for a traditional WAF. You have to rack and stack the appliance, configure, tune, retune the appliance in order to ensure a successful deployment. Now, next-gen WAF will provide out-of-the-box detection against OWASP Top 10, credential stuffing, virtual patching, and much more. Next-gen WAF is scalable, which allows for deployment of alongside cloud-native architecture. And a next-gen WAF deployment time is measured in hours or days, not weeks and months. Traditional WAF is perimeter-based. It may provide visibility for a specific platform. However, in hybrid environments, you're most likely going to be working with multiple WAF vendors in order to protect whatever applications are running behind it, regardless of whether it provides the same level of protection or not. In this setup, the challenge becomes focused on maintaining consistency of the WAF policy and application visibility across different platforms. The Signal Sciences WAF can be deployed in various platforms, providing flexibility with your hybrid cloud environment. In addition to the flexible deployment options, the web dashboard gives you visibility and control of your application API traffic in a single view while maintaining consistency of the WAF policy. Other WAFs, they're often black boxes that fail to provide comprehensive web attack context. They may block a request, but they make it hard to understand why they block the request. As I mentioned, our agent utilizes smart parse to make instantaneous decisions in line to determine if there are malicious or anomalous payloads present. You will get the granularity of information needed to correlate the request in your SIM tool or logs. And as development teams are transitioning from monolithic to highly distributed microservice-based architectures, we can be there. And then while this transition to microservice-based architectures has accelerated, and it may help in reducing the time to market for new apps and features, it also introduces new security risks by expanding the attack surface with ever-increasing distributed app deployments in production. Signal Sciences Cloud Native WAF completes the service mesh security picture by integrating directly with Istio and Envoy proxy to provide layer 7 visibility and protection to both north-south and east-west traffic in your Kubernetes cluster. The Signal Sciences agent can integrate with Istio and Envoy, offering DevOps teams an easy way to instrument their microservices within an award-winning next-gen WAF. With our integration, Envoy acts as the module, forwarding requests to the Signal Sciences agent for inspection and decisioning. By deploying Signal Sciences on Envoy, all services running behind Envoy are protected. Bottom line is, if you're scaling your application footprint to meet customer demands, we can be there to protect those apps and services that power them. Now, internal microservices. There's a lot of different assumptions made about internal microservices, which can lead to unforeseen security challenges. The classic example is a server-side request forgery attack. The attacker sends a URL to a vulnerable API that refers to an internal service. If the API doesn't validate the URL, it will make a request to the internal service that the attacker couldn't make themselves. This may allow the attacker to probe internal services for vulnerabilities, steal credentials returned from these endpoints, or directly cause actions via vulnerable APIs. One of the most notable breaches of 2019 was the Capital One breach, where the attacker used a server-side request forgery attack to retrieve AWS credentials that were then used to steal the personal information of over 100 million Capital One customers. Like I stated, the importance of protecting your microservices east-to-west traffic cannot be understated. Using only a legacy WAF at the perimeter could potentially leave 80% of your microservices traffic unprotected. I know that's a lot of words I've been throwing out there, but to bring it full circle to the question asked at the beginning of the presentation, how would you know when your apps, APIs, or microservices are under attack? In other words, what's the right information development, security, and operation teams need to identify a web app attack? Signal Sciences can help reduce the friction between teams by providing a true DevSecOps product. And on that note, I am going to hand it over to my partner presenting, Anil. He is going to discuss how to reduce friction between teams, the DevSecOps teams, and then finally go into a demo of our product. I will be turning off my video so that you can get the full experience of the demo. So, Anil.
Thanks, Orlando. Security teams often find themselves either supporting new infrastructure initiatives or inheriting legacy applications and systems. Implementing effective web defense tooling using a modern web app and API protection platform is key to bridging the gaps between old and new apps and infrastructure. With Signal Sciences, you're getting the most flexible deployment method, providing easy to use single pane view of your entire footprint, as Orlando mentioned earlier, and protects both internal and external sites and services. And essentially the total cost is less than a legacy WAF product, and we can easily integrate within your existing CI/CD pipeline. Just looking at hybrid environments, for example, a hybrid environment is going to introduce different technologies that commingle and communicate. A hybrid cloud environment opens up potential attack vectors. So in this scenario that you see here, an EKS cluster is using a Kong API gateway on the perimeter alongside a Go application that's running in an Envoy service mesh. We also have a legacy application deployed in our data center that interacts with our apps in the EKS cluster. There's an immediate need to shore up the attack surface, not only between the containers in our EKS cluster, but also between our legacy apps and our cloud-based apps. Signal Sciences can provide a holistic coverage of both monolithic and cloud-native applications. One of the keys to securing and defending modern applications and APIs is breadth of coverage across any infrastructure. Because the application has been decomposed from what were monolithic applications into smaller services and components, web defenses need to be spread out to those same delivery stacks. To get the necessary coverage, web protection tools should work across modern infrastructure. So things like major cloud providers like AWS or Azure or GCP, or containerized platforms like Kubernetes, Docker, or hardware platforms like load balancers or web servers, serverless options like API gateways, and various platform services like Heroku or IBM Cloud. Signal Sciences integrates natively with the Ambassador Edge stack which is a cloud-native API gateway and ingress controller for Kubernetes that's built upon an Envoy proxy. The Signal Sciences agent can be installed as a sidecar into each pod, which allows you to scale with the application. Depends on your use case, but the Signal Sciences agent can be deployed as a service for some specialized needs. To sum up, Signal Sciences' approach to web app and API protection can deliver active protection everywhere. See, secure, and scale across any app, any attack, with integration into any DevOps toolchain. Signal Sciences can provide visibility and protection for any application regardless of where it sits and the underlying architecture. Any cloud, container, platform as a service, or architecture. This level of support is unmatched by any other application security solution. Protection against OWASP injection-based attacks is just the tip of the iceberg, which, by the way, we can provide right out of the box with zero tuning or customization. The real value that our customers express is our ability to also provide business logic protection, such as application level DDoS or brute force attacks or account takeover attempts and API misuse and abuse, just for example. Lastly, being able to seamlessly integrate into any DevOps toolchain means development teams can obtain information surrounding their applications via tools they already use during the development process. Signal Sciences enables feedback loops that make data visible across development, security, and operations teams. So everyone becomes a security stakeholder and can respond proactively to potential security threats. This enables all teams to make decisions from the same layer 7 attack insights and attack timelines to identify and or remediate incidents faster. You're already using a security tool to monitor, coordinate, investigate, and respond to security incidents. But Signal Sciences enables security teams to do further analysis and correlation of the web layer attack data that we collect using our REST API. The request data can be ingested by your SIEM or other API-capable security tool. Here, this screenshot that you see on the slide shows a list of flagged IPs and raw request data, metadata that's collected from Signal Sciences, which is now visible in Splunk. This allows the team to analyze and correlate the data across other log sources in Splunk. We show you what's happening at layer 7, but we can be used in conjunction with other services to get a deeper view. Your cost of ownership is lower because we seamlessly integrate with other security systems. Uptime and availability are crucial to operations teams chartered with keeping apps running and available to service customers. Signal Sciences built the agent to expose metrics that operations teams rely on and can surface metrics that are meaningful to operations teams like client-side and server-side errors, or large response times, or response errors, or broken links in the code. These data points can point to critical issues either in your application's business logic or server configuration, and helps teams triage issues faster. We also built our APIs so these metrics pull into the systems your operations teams already use. Other WAF and RASP vendors don't have APIs for the metrics and provide little detail in their UI. The goal is to allow developers to write code without introducing roadblocks from the security team. Signal Sciences provides visibility into the security and the performance of an application. In this screenshot, you can see the drop in request volume of around 10 million requests per second. The client was able to use our dashboard cards for visibility and track down a noisy API endpoint. The development team took this feedback and modified the API to push rather than pull data, reducing the request volume by 9% in the quarter. Signal Sciences helps provide actionable information. With Signal Sciences, you'll have the insights to determine if your app is under attack or if you're seeing errors resulting from a bad code deployment. So to summarize, the Signal Sciences platform provides the following: an integrated platform with low total cost of ownership, protection in any infrastructure, whether it's monolithic or microservices based, seamless integration with your existing security and DevOps tools. And from an architectural standpoint, the agent and module pairing with our cloud-based decision engine provides a flexible deployment, stopping a web layer attack by identifying OWASP injection attacks out of the box. And finally, a unified view of your application traffic across your environment, regardless of the platform. Now I'll be going into the demo section of the presentation. I have two examples for you today. So the first example is going to be how we deploy Signal Sciences in a traditional monolithic environment. Here we're going to use an Apache HTTP server that's running on Ubuntu. And we're going to leverage a configuration management tool such as Ansible to deploy Signal Sciences within a matter of minutes. And for our second example, we're going to show how Signal Sciences can be deployed in a microservices environment. Here we have an Envoy proxy running in a Docker container. We're going to be able to configure the agent and module with Envoy right in the Docker file. Just to provide a little more context, and just around how our agent and module works, more specifically with Envoy, this diagram shows how the request flows through Envoy and to the Signal Sciences agent to determine whether to allow or deny the request from being processed by Envoy. So let me go ahead and actually switch over to my demo here. As I mentioned, the first example is going to be a deployment of the Apache module and Signal Sciences agent on a monolithic environment. Here I'm going to use Ansible to actually deploy my module and agent. I have an inventory file that allows me to specify the Apache servers that are in my environment. And so this is an example of what a host file would look like. So I'm showing, I have my inventory list here. And what I'm doing in the playbook is I'm actually referencing my Apache servers, which is where I'm going to install my Signal Sciences agent and module. We also have what's called agent key pair, which allows me to specify the agent keys that I'm going to use to be able to actually pair the agent with my Signal Sciences dashboard. And so I'm specifying that here in the var files. So I'm actually going to kind of show you a little bit about what happens in the playbook. First, what we're going to do is we're going to add the Signal Sciences repository. Then we're going to install the Signal Sciences agent. We'll add the agent keys. Then we'll start the agent. And then we'll install the Apache module. And then restart the Apache services. So let me go and actually get that rolling. All right, I gotta go to my directory. And so for anyone who's familiar with Ansible, you do have to escalate your privileges in order for us to be able to install the agent. So you can see here, I've already started adding the repo. We're getting the agent installed right now. And then now we're adding the agent keys. And now we're installing the Signal Sciences Apache module. And we restarted the Apache services. And so let me go and actually share my Signal Sciences dashboard here. This is what it looks like. And so when I go to the agent page, you can see that my Apache server just showed up 15 seconds ago. And so now let me go ahead and actually go to the second example. And I'll show you the Docker file here. And so in this example, like I said, this is an Envoy proxy. So all we're doing is we're actually pulling the Envoy proxy from the standard Envoy image. We're going to install the Signal Sciences agent, and we'll add the agent keys, and then configure our Envoy proxy. So I actually have a make file set up here to actually go through the process of building and creating the image and container. I'm going to just run that right now. Let's see. I'll run my make build command. So it's going to build the Docker image. And for those of you who are familiar with Docker, you could actually, once you build the image with our agent and module, you could essentially use this container image to deploy as part of your Kubernetes cluster deployment. And so while that's happening, I'm not sure if there's any questions, but if you do have any questions, feel free to post those questions in the chat. But this should take just a few more seconds. As soon as this is done, we'll go ahead and just double check, make sure that the image has been built, which it has. Perfect. Okay. And then so I'm going to actually go ahead and run the container. And so now the container is running. And so I've installed this as a container on my local host. It's running on port 4000. So let me just make sure that the agent, first of all, shows up, which it does. Perfect. Okay. So if I go to my local host, it's actually the Envoy proxy is set up to route me to google.com. Now, I actually have a rule set up in Signal Sciences to be able to detect for your standard OWASP injection attacks, and it's going to block those attacks. So I'm going to just write a quick and dirty cross-site scripting attempt here. And so once I do that, you can see that I actually get a 406 response. This is the Signal Sciences agent blocking that request. So let me go to the request page, and it'll just take a few seconds for the data to populate. But once that shows up, you'll be able to see that I was able to block the cross-site scripting attempt. To kind of show you a little bit more while we're here in the Signal Sciences dashboard, you can actually set up your own rules. So if you wanted to define a specific type of request condition, you can choose from all of these fields within the rule builder, and you can actually specify what you want to do with that request. So for example, if I wanted to look at requests that were hitting my API endpoint and my path is /API, and for example, if I'm an organization that does not allow or does not do business or anything with anyone outside of the US, I could actually create a condition to say if the country does not equal United States, then I'm going to actually just block that request outright. And just for further visibility within Signal Sciences, you could add a signal. And so what this does is when I add my signal, and I'm just going to say not US, I can create my custom signal right in the UI here. And then I'm going to go ahead and actually save that rule. So now every time I see a request that hits my API endpoint that's from outside of the US, I'm going to block it, but I'm also going to be able to see it in my Signal Sciences dashboard. Also, I kind of showed you earlier a bit of this dashboard view here. These are all of the signals that come built in within Signal Sciences. So you've got your standard OWASP injection attacks. We're identifying the SQL injection, cross-site scripting, command execution, the directory traversal. But we also identify various types of scanning tools. We can identify where the traffic is coming from. We can identify various types of request anomalies, if the user agent is missing or if it's a search bot imposter. So these are things that we can identify as anomalies. And then we also look at response anomalies. I showed you earlier, there was an example of a response anomaly for a specific customer. They were able to make changes in their code to be able to reduce that. And so this allows you to at least see if there's any sort of anomalous behavior happening as a result of either a code change or just maybe someone trying to enumerate across your app or API. And that is pretty much it for the demo. I'll go ahead and actually swap it over for questions.
Great, great. We've got some good questions lined up here. I'm just gonna, while I'm doing the questions, I'm just gonna pop on the webcam. So let's see, first one, can we use the next generation web application firewall with our current CDN? So talk about CDN compatibility. I don't know who's best for that. Go ahead and take it, whoever it is.
Yeah, so that's a good question. So, for anyone who is using a CDN, you can certainly use our product in line with the CDN. Most of the customers that I've worked with that currently do use a CDN will still deploy Signal Sciences because we're going to be most likely deployed in line with their application. So they could still currently use their CDN if they wanted to. But we also have a Cloud WAP offering, which allows you to deploy our Signal Sciences reverse proxy in front of your application, and it's a hosted reverse proxy. So you don't have to worry about managing our, your module and agent, and we essentially act as almost like a CDN from that perspective.
Okay, great. Anything to add to that? We good? That seems like a pretty complete answer. All right, next question from our audience. And by the way, thank you, audience. We still have time for a few more questions, so enter those into the questions tab. Next question is, what kind of visibility or telemetry helps developers make the code more attack resistant?
I guess I could take that, Neil. I think you showed a good example of that in that API example where you had a noisy API endpoint and the telemetry as far as the error codes, the response codes from the server. One good example could be SQL injection, right? Typical server response would be a 500. So if you see a bunch of signals with SQL injection and a 500 response code, that definitely indicates SQL injection attempts. However, if you see that trend and then all of a sudden you see a server response code of 200 and the response size is increased and we tag it with SQL injection, that could potentially indicate successful data exfiltration. So not only can you identify the attack, but you could also correlate that data and potentially see what the attacker is trying to accomplish. So hopefully that answers or addresses the question on what kind of security telemetry you could get from our product.
Definitely sounds very helpful. Sure everybody can improve at their ability to write secure code. Next question from the audience is, do you defend against financial attacks designed to heavily consume cloud resources? Could an attacker cause us to have much higher expenses by sending us lots of traffic to the cloud service?
Okay, I could chime in first on this. That's a good question. And then I'll let Anil jump in if he has anything to add. As far as defending against high volume traffic, we do offer advanced rate limiting. So you would be able to set the threshold of what is acceptable for your environment. If that threshold is exceeded by an IP, then you could block subsequent requests to that API, that endpoint, that application. And this would allow you to throttle or limit the request from that resource that's trying to send a bunch of requests. That would be, I think, the initial approach is using rate limiting to threshold those requests. Anil, you want to add anything to that?
Yeah, no, that's a good point. I was actually going to talk about rate limiting as well. So yeah, we do have application layer rate limiting, which could help really identify, when there's excessive requests being made to a particular part of your application, or we can identify those types of attackers that may try to abuse your APIs or application. But yeah, I think that's the best option in terms of what we can provide there.
Excellent, great. Thanks, James, to you also for that question. Let's see, next, you mentioned that in hybrid environments, more than one web application firewall can be used. Where is Signal Sciences most likely to be deployed in a hybrid cloud environment?
That's a good question. I mean, I can answer that, Orlando, if you want to add to that later. But basically, you can be deployed in your application layer. You could be deployed. You could deploy Signal Sciences as a reverse proxy. You could deploy us within the if you're using Nginx as your load balancers, you could deploy us there. So we can pretty much be deployed in any area of your environment. It just depends on the architecture, and it depends on the where you would like to most likely see that get that application layer visibility. Actually, I was going to show you an example of a. Oh, sorry. I don't think I have that page anymore, but yeah, there's. Oh yeah, here it is. Here's a list of all of our modules that we have available. So we could pretty much deploy in any of these web server or language specific modules, and as I mentioned before, reverse proxy or cloud WAF as alternative options.
All right, great. Let's see, another question we have. Our operations team monitors our cloud infrastructure with an app monitoring service. Which will Signal Sciences play nice with a third-party service like this? I'm guessing they're talking about things like New Relic and Data Log and services like that.
You want to take this, Anil? I think it would be good to show the integrations. The answer is yes. Yes, we definitely can integrate, and we can show you the list of integrations, which are several out-of-the-box integrations. And as we said, everything you're seeing here in the dashboard is API first. So if we don't have a one-click integration, more than likely you can use our API to pull any data and out of our system and integrate with third-party systems.
All right, great. Just if I had a question I wanted to throw in too, who is most likely to reach out to you, to Signal Sciences? Is it the developer community? Is it the traditional network security folks? I'm just curious about if developers might be interested in bringing this product in, how they might take it and kind of sell it to their internal security teams, or is it usually the other way around?
My experience has been kind of mixed. I've worked with DevOps teams, or I've worked strictly with security teams, and the dev teams would get involved here and there. So it's been kind of mixed. But I guess it depends on the size of the organization and what they're trying to protect. But yeah, I mean, I would say that there are times where you would work with the DevOps team, and you'd be working only with them to help deploy our product and protect their apps.
Good. Well, it sounds like either path is doable then. That's good news.
Yeah, I think the more enterprise clients, they're the ones that are, because there's a little bit more of a responsibility on the security teams to deploy Signal Sciences. So you're working more with the security teams there versus with maybe a smaller organization. It may be one person doing everything. So.
Great. We also had a question. Someone was asking for clarification on east-west traffic, north-south traffic. Can you help?
That's a great question. I apologize if we didn't go over that enough and define it, because it used new terminology, right? A buzzword. So what is meant by north-south is usually your ingress traffic coming from the outside of your perimeter into your application. And then what's meant by east-west would be your internal microservices traffic. So any kind of services that are communicating to each other internally, right? It could be an API, it could be some sort of system that is communicating with another system internally. So that is what's meant by the east-west. It would be your internal communications between systems and microservices.
Great, kind of a thinking of it as a network and software way from both standpoints. That's awesome. Well, it looks like, unless we get a last minute question here, it looks like we've exhausted. You guys have done a great job, both with your presentations, demo, and also answering questions here. So it looks like we're good on questions. So I'm gonna go ahead and wrap things up. Let's move on. We're kind of closing things out here. I want to announce our 4 winners for the Amazon gift cards. Those are Jennifer G, Mitchell W, that's not me, somebody else, James M, and Jamie S. The folks at MediaOps who run DevOps.com will be reaching out to you to help get those gift cards. So that's exciting. Glad that you won those. Well, there's also some other great content. If you go check out DevOps.com, we have lots of webinars, great content, things that companies like Signal Sciences contributes, and we're very happy to have them sponsor the webinar today. So Orlando, Neil, great job. Thanks for your presentations today.
Appreciate it. Thanks, Mitch. Thanks for having us.
Thanks for having us.
You bet. It's been my pleasure. I do want to say thank you to our audience. You know, you spent close to an hour of your time with us. Your time is super valuable, and we really appreciate that you spent it with us. We're honored that you did. It's been my pleasure hosting the webinar today. Be safe, be well, and be careful out there.